Okay, a little more fact checking about alkenes. Why are alkenes considered unsaturated hydrocarbons? Well, what does saturated mean? It means it's holding as much hydrogen as it possibly can. If you have a structure like this, where, let's see, this carbon can have up to 4 bonds. It's using one there, so it has 3 more available. This carbon's using 3 bonds, so it has one left to hold a hydrogen. This one's using 2 bonds, so it's got 2 spaces left to hold a hydrogen. If you look at this and say, could you fit any more hydrogen onto here? The answer is, well, yeah, if you don't mind doing a little rearranging. We could snap one of these bonds. It wouldn't break the molecule. It isn't necessary to have 2 there. We could pop one of those. And what that does, because a bond is a pair of electrons, that would mean this carbon's now got another bond free. This carbon's got another bond free. And that means we could add on more hydrogen. We could now make this CH3. This would become CH2. Now it's saturated. Anytime you have an alkene, it means somewhere in there is a double bond, which means some potential hydrogen is being missed out on. And that means alkenes are always, always, always unsaturated. You're wasting some electrons on double bonding where you could be holding more hydrogen. What's the first member of the alkene family? Well, if you look on your list of carbons, meth is the first prefix. And so we're trying to get you to say methene here so we can jump all over you. You can't have methene, and why not? Because where's the double bond going to be? If you're going to have a double bond, there have to be 2 carbons, one on either end of it. And so the simplest alkene you could possibly make is this one, which we call ethene, which contains, let's see, this would be CH2, and this would be CH2. That's the condensed structural, so I guess the full-on diagram would be like so. Double bond to another C. There we go. There's your full-on molecule for ethene. So alkanes, the first member is methane with a single carbon. But for alkenes and for alkynes, which are coming up very soon, where there's double and triple bonds, you can't do less than 2 carbons because it takes 2 to form a double or triple bond. Name the following structure. Why is no number needed? There are 3 carbons in this, so it's prop something. It contains a double bond, so it's propene. Now, we do not normally say prop1-ene. Why not? It's because if you number this from the right, it's prop1-ene. If you put the double bond over here, then you'd number from the other end, and it would still be prop1-ene. Now, conceivably, you could have 2 double bonds like this and get something that you might call prop1,2-ene. However, technically this is supposed to get this is called a diene because it has 2 double bonds in it, and so this should be prop1,2-diene. And the fact that there isn't a di in this name tells us that this isn't happening. There's only a single bond. So, in this case, the only place this double bond could possibly be is on carbon number 1 because we use the numbering that will give us the lowest possible number. You would never say prop2-ene. That would just mean you started counting from the wrong end. So that's why instead of prop1-ene, people will usually just chop this down to propene, and they won't bother saying this. It's because the alternative would probably be called prop1,2-diene, and you would never say prop2-ene, so what's the point of having a number at all?